Hi, I'm Kaiyu. I'm going to do the question 1 of homework 3 for probability and stochastic processes. The problem 8, find B so that P of x equals k represents a probability mass function. We know that if P is a probability mass function, then the sigma from k equals 1 to infinity p x equals k must be 1. So this one is b times k times p to the power of k minus 1. And then we can let this term be as infinity, and it will be 1 plus 2 times p plus 3 times p squared to the infinity, and this is the first equation. And then we multiplied by p on both sides. So the left side would be p times s infinity, and the right side would be p plus 2 times p squared plus 3 times p cubed to the infinity, and this is the second equation. And then we can left the first equation minus the second one, so the left side would be s infinity minus p s infinity, and the right side would be 1 plus p squared plus p cubed to the infinity. And this term, when the absolute value of p is less than 1, and it will be 1 over 1 minus p, and we know that the p is between 0 and 1, so it is equal to 1 over 1 minus p. So the left side is 1 minus p times s infinity, and the right side is 1 over 1 minus p. So the s infinity will be 1 over 1 minus p squared. So we have b times this one equals 1. So b equals 1 plus p squared. The problem B, we need to find the expected value of x. We know the expected value is the sigma from k equals 1 to infinity k times p of x equals b. So we can rewrite this term as b times sigma k equals 1 to infinity k times p to the power of k minus 1. From the problem 8, we know that the sigma from k equals 1 to infinity k times p k minus 1 is 1 over 1 minus p squared. So we can multiply by p on both sides. So we can get the sigma k equals 1 to infinity k times p to the power of k is equal to p over 1 minus p squared. And then we take the derivative with respect to p on both sides, and the left side will be the sigma k equals 1 to infinity k times p to the power of k minus 1, and the left side will be 1 plus p over 1 minus p cubic. We notice that this term, we can use this term to calculate the expected value. So the expected value is b times this term, which will be 1 plus p over 1 minus p cubic, and the final result will be 1 plus p over 1 minus p. The problem C, find the expected value of x squared. We know that the expected value of x squared we can rewrite as the sigma from k equals 1 to infinity k squared times p of x equals k. So we can use the same method as the problem B. We know that this term sigma k equals 1 to the infinity k squared times p to the power of k minus 1 is 1 plus p over 1 minus p cubic. So we multiplied by p on both sides, and the right side will be p times 1 plus p over 1 minus p cubic. And then we take the derivative with respect to p on both sides, and the left side will be the sigma from k equals 1 to infinity k cubic times p to the power of k minus 1, and the left side will be 1 plus 4 times p plus p squared over 1 minus p to the power of 4. So the expected value of x squared is b times this one, and the final result will be 1 plus 4 times p plus p squared over 1 minus p squared. On the problem B, find the expected value of find the expected value of x squared minus the expected value of x squared. And we can get the expected value of x squared from the problem C, which is 1 plus 4p plus p squared over 1 minus p squared. We can get the expected value of x from the problem B, which is 1 plus p over 1 minus p, and then we take square. So the final result will be 2 times p over 1 minus p squared. Okay, the problem E, let p equals 1/3, and we need to find the contradictional probability mass function x equals k when x is between 2 and 5. At first, we know p is 1/3, so we can calculate b. B is 1 minus p squared, so it is equal to 1 minus 1/3 squared and equals 4 over 9. And then we can rewrite the conditional probability as p of x equals k and x is between 2 and 5. over sigma from k equals 2 to 5, p of x equals k. And then we can calculate this term. This term is sigma from k equals 2 to 5, 4 over 9 times k times 1 over 3 to the power of k minus 1. And this term is approximately equal to 1 over 0.5377. And then we can write the contraditional probability mass function, and it is 1 over 0.5377 times 4 over 9 times k times 1 over 3 to the power of k minus 1, when k is equal to 2, 3, 4, 5. And when k is equal to other values, then the probability mass function will be 0.